Hello guys! Today, we're going to talk about simplifying rational expressions. Before we start, let us know, what are rational expressions? Rational expression is a ratio of two polynomial expressions in the form of r of x is equal to p of x over q of x, where p of x and q of x are polynomials and q of x cannot be 0. To make it simple, rational expression is just a fraction with variables. That's it. When we first started learning about fractions or rational numbers, we learned about the idea of putting things in lowest terms. So, if we saw something like 3 over 6, we knew that 3 and 6 share a common factor. We know that 3 could be written simply as 3 times 1, while we could write 6 as 2 times 3. And since they share a common factor, the number 3 in this case, we could divide both numerator and denominator by 3. Or we can simply cancel it out. And in lowest terms, this fraction would be 1/2. Now let us start with our first example. 14x to the 6th power all over 35x squared. Go ahead and simplify this expression. We can reduce 14 and 35 by 7, for this is their common factor. 14 divided by 7 is 2. 35 divided by 7 is 5. Now, whenever you divide a common base, you're allowed to subtract the exponents. 6 minus 2 is 4. So, the final answer for this problem is 2x to the 4th power all over 5. Now, you can also see it in this way. Let's go back to the start. We will write the factors of 14 and 35. 14 is 7 times 2, and x to the 6th is basically 6x variables multiplied to each other. 35 is 7 times 5, and x squared is just x times x. In this lesson, we're focusing on canceling and simplifying. We cancel a 7, and we cancel 2x variables. So now, we are going to multiply the remaining numbers and variables with each other. We have a 2 on top and 4x variables remaining, and a 5 on the bottom, which is why 2x raised to the 4th power over 5 is the answer. Now with our second example, x squared minus 49 all over 2x minus 14. For this example, we are going to use the 3 steps in simplifying rational expressions. The first step in simplifying rational expressions is to factor out the numerator and denominator as much as possible. We should remember that we should always try to factor the numerator and denominator as much as we can. So let us first try to factor the numerator. X squared minus 49. How do we factor that? When you have something that looks like x squared minus the number, and that number is a perfect square, something like 4, 9, 16, 25, 36, 49, it can be factored into x plus a number, times x minus that number, where the number in this case is 7, since 7 squared is 49. And if you did multiply these all out, FOIL it out and simplify, you would get this. You would get back to this x squared minus 49. That's great. So we factor the numerator. Let's factor the denominator, 2x minus 14. Remember, the first thing is to see if there is a number that we can pull out front. A number or an x a variable that you see in all the terms that you can just pull out front. There is no variable x that's in both terms, but there is a number we can pull out up front. The factors of 14 is 7 and 2. So, 2 is in both of those terms, so we can pull it out front. And what it will leave behind inside is an x from the first term and a 7 from the second term. So it factors into 2 times x minus 7. The denominator is factored, the whole expression is factored. Whatever you're given, factor it as much as possible. And now, to actually simplify, here goes our second step in simplifying rational expressions. Cancel factors that are the same on the numerator and denominator. We're going to get rid of cancel off any common terms. Cross out anything you see that is the same on the numerator and denominator. So the x minus 7 and the x minus 7. And now, to our last step, we're just going to rewrite any remaining expressions in the numerator and denominator. So let's write what's left behind. So this is as far as we can go. When nothing else can be cancelled, we've truly simplified it or reduced it to the lowest terms. This is our final answer. X plus 7 all over 2. Here's another example. X squared minus 16 divided by x squared plus 9x plus 20. What do you think we need to do in this problem? Your goal is to factor completely as possible and cancel. We already know how to factor x squared minus 16 using the difference of squares technique. It's going to be x plus 4 and x minus 4. You just got to take the square root of x squared, which is x, and the square root of 16, which is 4. Now, in the example, in the denominator, we have a trinomial with a leading coefficient of 1. To factor it, all you need to do is to find two numbers that multiply to 20 but add to 9. This is clearly 4 and 5. So it's going to be x plus 4 times x plus 5. And we can clearly see that x plus 4 will cancel. So, the final answer is x minus 4 divided by x plus 5. And that's how you could simplify rational expressions. But there's one more example I'm going to go over. 5 minus x all over x minus 5. These two look very similar, but they don't cancel immediately. Whenever you see a situation like this, factor out a negative 1. It could be from the numerator or denominator. I'm going to take it from the numerator. If I take away negative 1 from this x, it will change to positive x. And write the x before you write the 5, so reverse the order. If I take out a negative 1 from positive 5, it will change sign and it will become negative 5. So notice that we can cancel x minus 5 at this point. So the final answer for this is negative 1. Now let's simplify this expression. 72x to the 8th power y to the 7th power divided by 64x to the 5th power y to the 4th power. 72 is basically 8 times 9. X to the 8th power is x to the 5th power times x cubed because 5 plus 3 is 8. Y to the 7th power is y to the 4th power times y cubed. 64 is 8 times 8. And now we will just copy the remaining terms. Now, we could cancel an 8. We could cancel x to the 5th power, and we could cancel y to the 4th power. So the final answer that we have is what we left over. On the numerator, we have a 9x cubed and y cubed. And on the denominator, we just have an 8. So, that's the answer. Now let's move on to our last example. So let us try this one. 5x squared minus 15x divided by 8x minus 24. So in the denominator, we can take out the GCF, the greatest common factor, which is 8. 8x divided by 8 is ax. Negative 24 divided by 8 is negative 3. In the numerator, we can take out a 5x. 5x squared divided by 5x is x. Negative 15 divided by 5x is negative 3. So we could cancel the common term, x minus 3. So the final answer is 5x divided by 8. And that is how you simplify rational expressions. Thank you for listening.